Okay, so now we have been given quadratic equation in vertex form, which indicates our transformations. So our parent function is f of x equals x squared. And then our transformed or vertex equation is as follows. So we are going to use the order of operations to list the sequence of our transformation. So if you were doing order of operations, like if you knew what x was, what would you do first? You would first do your parentheses. So we're going to talk about the horizontal shift. Then you would do multiplication, so parentheses, and then multiply. So then we'll talk about the dilation as well as the reflection. And then lastly, in order of operations, you would subtract or add last. So we will talk about the vertical shift last. So we have a horizontal shift, we have a dilation, we have a reflection, and we have a vertical shift. So number one, this graph was shifted left 5 units. This graph was stretched, so we have a vertical stretch by a factor, which means we multiplied, okay, of 4, just the positive part. The negative indicates a vertical reflection across the x-axis, which is y equals 0. And then lastly, we shifted down 8. We have a horizontal shift, we have a dilation, we do not have a reflection, and we have a vertical shift. So we're going to go 5 units left. My A is between 0 and 1, so this is a vertical compression at a factor of 1/4, and then we shifted 8 units up. We have a horizontal shift, we have a dilation of 1/4, we have a reflection of the negative, and then we have a vertical shift. So this time we're going to go 5 units to the right. We're going to have a vertical compression by a factor of 1/4. 3, we're going to have a vertical reflection across the x-axis, which is y equals 0. And number 4, we're going to go up 8. Okay, now let's take a look at these same problems. We're going to give all the critical features here. So our vertex is -5, -8. So -5, -8 is somewhere in quadrant 3. Our axis of symmetry is -5. This is going to help us with increase and decrease. So our graph is negative, so that means our parabola turns down. There will be no roots, no real roots. So now let's do increase and decrease. So, and then x equals -5, and then we have positive infinity. So let's talk about the increase. So our graph is increasing on the the left side of the AOS. So from -infinity up to -5, my graph is increasing. And then we'll go with purple. And then my graph is decreasing from -5 to positive infinity. And then our end behavior, as x approaches -infinity, f of x approaches -infinity. as x approaches positive infinity, f of x approaches negative infinity. So these two both are negative infinity. They both turn down. Okay, our vertex for number 17 is -5, 8. So this is up here. Our A is positive, so this graph turns up. No real roots again. My AOS is x equals -5. Which is going to help us with our increase and decrease intervals. So our graph is increasing on the right side. So from -5 to positive infinity, we increase. And then from on this left side of the AOS, my graph is going down. So from negative infinity to -5, it is decreasing. My M behavior is both going up. So as x goes left on the graph, f of x goes up. As x goes right, f of x goes up. My vertex for number 18 is 5, 8. That puts me in quadrant 1. My graph is going to turn down because a is negative, so I would have 2 real roots. My AOS is x equals 5. This is going to help with increase and decrease. So my graph is increasing on the left side of the AOS. So from negative infinity to 5, those x values cause the graph to increase. And then my graph is decreasing on the right side. So from 5 to positive infinity, those x values cause the graph to go down. My M behavior is turning down. As x approaches negative infinity, f of x approaches negative infinity. As x approaches positive infinity, f of x approaches negative infinity. Again, both of these are going down.